this question is using proportionality, and we have the two different cat types, the cheetah and the lion, and we're using it to model between the mass of the weight of the animal and then their shoulder height. And it tells us in the question quite early on that it's directly proportional to the cube. So that means that the mass of the animal is proportional to the cube of the shoulder height, which they're calling h. So it's the cube. So we're going to be using that relationship throughout the question. So for part A, we're told that a cheetah has a mass of 64 and a shoulder height of 0.8. So this is specific to the cheetah. And from that, we can start to find what that relationship is more specifically, so that we can then find m in terms of h. So we know that instead of having this symbol here, we can change this to a linear relationship, which is that m is equal to something times h cubed. And we're trying to find out what that something is. We tend to use k when it's proportionality. So 64 is equal to k, and then we have 0.8 cubed. And that's just from the first part of the question. We're told that when it's 64 kilograms, there's a height of 0.8 meters. I can then just type that into numeric solver and find what my k value is. And k is equal to 125. So I now know more specifically that the relationship is m is equal to 125 h cubed. And that's the first part of the question, which is asking us to find an expression for m in terms of h. So m in terms of h. For the second part of the question, so this is part I, for part II, it says for a different cheetah, if the shoulder height is 0.75, we need to find the mass. So we know the equation is m is equal to 125 h cubed. I now know that the h, the shoulder height, is 0.75. So m equals 125 0.75 cubed. And I can just substitute that into my calculator and find that it's 52.7 kilograms to 3 significant figures. Part B, we're told that there is this Rubner's law, and it states that the energy needed for an animal is directly proportional to the square of h. So now we can write a new equation, which is E is proportional to h squared. And we're asked to find the energy needs for a lion, that's 220, and for a cheetah, that is 64. Now in this equation we're working with, there is no mass, so that means that I need to first of all find what the equivalent h value is for both of these two values. Now looking at the question, this 64 kilograms is what I've already worked out for a cheetah. So in terms of the cheetah, I already know that the h value is 0.8 for the mass of 64. But I now need to find that same information for the lion. So going back to part A, I know that the mass is equal to 125 h cubed. And I'm trying to find what is the h value for a lion that is 120 kilograms. So I can put that into my numeric solver and find that h is equal to 1.21 meters to 3 significant figures. So now that I know that, and again, sorry, that's for a mass of 220. So now that I know that, I have this equation, which is E is proportional to h squared. So for a lion, that means that E is equal to k, and then it's 1.21 squared, because I now know that the height of this weighted lion is equal to 1.21. For the cheetah, I know that the energy is equal to k times, and again, I don't know the k, but it's 0.8 squared, because again, I know that for a mass of 64, the h value is 0.8. Now I'm told that the energy needs of a lion are k times the energy needs of a cheetah. So that means that I'm going to then write these two things together. So the energy needs of a lion are k times greater, or k times the energy of a cheetah. So that means that if I take the lion, which I have k times 1.21 squared, and make that equal to k times the cheetah, which is k 0.8 squared. So all I've done here is take the cheetah and take the lion. And we know that the lion is equal to k lots of the cheetah. And if I simplify that, I have k 1.21 squared is equal to k squared 0.8 squared. And if I graph both sides, so I can go to my calculator here, and I'm just going to graph the two different sides of the equation, but replacing the k value with x. So I have x times 1.21 squared. So that's the side for the lion. And then we have x squared times 0.8. So if you want to delete, you just press the delete button here. So 0.8 squared. And from that, I can just graph them and then find where my intersection is in order to solve it. So there's some sort of intersection around here, which is a 0, 0. Let's see if there is another one as well. Oops. So zooming in. Yeah, we can see there's a second one over here. So let's extend that value to 5. Yeah, we can see there's a second one here that we need to look into. So intersection, and we can see there that it's at 2.29 to 3 significant figures. So if I go back, I can see that k equals 2.29. And now I know the relationship between the two. So that's the answer for the second part there.